something that can be quite useful in trigonometry is when we look at special triangles. Now there's two different special triangles that we're going to look at. Ones that have an angle degree of 30, ones that have an angle with a degree of 45, and ones that have an angle with a degree of 60. Now 30 degree and 60 degree triangles are the same triangle. And our second triangle is going to be a 45, 45, 90 triangle. So the first one we're going to look at is going to be the 45, 45, 90 triangle. So if I have a triangle that has an angle of 45 degrees, I know that the other angle must be 45 degrees, making it an isosceles triangle. If I assign a side length for the opposite of 1, that means that the other side must also be 1. We can calculate the hypotenuse using Pythagoras' theorem. So if I go 1 squared plus 1 squared, that's going to equal c squared, which then we know 1 plus 1 equals c. And then we know if 1 plus 1 equals c squared, we know 2 equals c squared, which gives us that c equals the square root of 2. So for every 45, 45, 90 degree triangle, we know that the ratio of the sides is 1 to 1 to root 2. Now knowing this, we can get the exact value of our trig ratios. So knowing that the tangent is opposite over adjacent, we can calculate that the tan of 45 is always going to be opposite, which is 1, over adjacent, which is 1, which is 1 over 1, which means the exact value of the tan of 45 is always going to be 1. We can also do this for the sine of 45. The opposite of 45 is going to be 1. The hypotenuse of 45 is going to be root 2. So the exact value of the sine of 45 is going to be 1 over root 2. Similarly, for the cosine of 45, the adjacent is 1, the opposite is, or the hypotenuse is root 2. So we get 1 over root 2. We can do the same thing for a 30, 60, 90 triangle. Now we get the sides of a 30, 60, 90 triangle if we know that a 30, 60, 90 triangle is an equilateral triangle that's been folded in half. So we know an equilateral triangle has angles of 60 degrees. So we know that if we assign the side length of a 60, 60, 60 triangle as 2, when we fold it in half, that means our other leg's going to be 1. We can use Pythagoras' theorem to calculate the third side, which is going to give us the square root of 3. So using this similar triangle, we can calculate, the tangent of 60 to be equal the opposite, which is root 3, over the adjacent, which is 1. We can calculate the sine of 60 to be the opposite. We can calculate the sine of 60 to be the opposite, which is root 3, over the hypotenuse, which is 2. And we can calculate the cosine of 60 to be the adjacent, which is 1, over the hypotenuse, which is 2. You could do the same thing for the 30 degree angle as well. So the tan of 30 is going to be 1 over root 3 because it's opposite, which is 1, over your adjacent, which is root 3. Your sine of 30 is going to be the opposite, which is 1, over the hypotenuse, which is 2. And the cosine of 30 is going to be the adjacent to 30, which is root 3, over the hypotenuse, which is 2. So this is a very useful skill if we want to know the exact value of our sine, cosine, and tangent ratios.